let's start our presentation with the introduction of reactor. Chemicals are produced in industrial plants in reactors ranging in size from a few centimeter cubic to massive structures. Many variables affect reactor design, but the thermodynamics and kinetics of the chemical reactions being carried out are especially important. Batch and continuous reactors are the two main types of reactors. Batch reactors are used when a company wants to produce a variety of products involving different reactants and reactor conditions. Meanwhile, continuous reactors are typically installed when large quantities of a chemical are being produced. It is crucial that the reactor can run for several months without stopping. In this study, the reactor that will be used and focus is glass-lined reactor. Glass-lined reactors, also known as MSGLR, mild steel glass-lined reactor, SSGLR, stainless steel glass-lined reactor, and enamel reactors, are carbon steel reactors with a consistent thickness glass lining. This glass liner enamel is present on the reactor's inner surface, which is in touch with the reaction mass. It is used because it is compatible with a wide range of chemicals. The reactor is a vessel with an agitator that enables chemical mixing in a controlled environment. The top section of the reactor connects the process nozzles, which bring in the chemicals and gases as needed and allow for cleaning of the head nozzles. They come in a variety of sizes, ranging from 63 to 16,000 liters.
Firstly, mechanical seal. It uses to prevent the fuel used by a machine from leaking to the external environment. Jacket. The function of jacket is to control the temperature of contents with a cooling or heating jacket around the reactor. Besides baffle, it can prevent the swelling in agitation by converting the swelling into a desired flow pattern. The next component is stirrer. Its role is to homogenize the suspension. In addition, bottom valve is the component used to drain the contents of the vessel. And lastly, manholes used to allow inspection, maintenance, and system upgrades.
Now, I will explain the applications of glass-lined reactors in industries. Glass-lined reactors are most commonly used in pharmaceutical industries of mixing reactions. Besides that, the chemical, petrochemical, pesticide, metallurgical, and food sectors also make extensive use of glass-lined steel process equipment. This is due to the glass ability to withstand with acids, since most reactions in pharmaceutical and other industries requires acidic reactions. However, glass-lined reactors are not preferable in alkaline or basic reactions because glass cracking may happen at higher pH, especially borosilicate glass that commonly used in this setup. Borosilicate glass readily acts and degrades at higher pH conditions, which is undesirable. Instead, stainless steel reactors can be a better option to be used in reactions involving strong alkaline solutions. Glass-lined reactors can be found in several colors according to their specific features. There are blue, light blue, green, and white in color. The first one is the blue reactor. Blue reactor has higher thermal conductivity and wide range of pH acceptance. The second one is a light blue reactor. Light blue glass-lined reactor has higher resistance to alkali and easy for visual observations. Meanwhile, green reactors are suitable for operations at higher temperatures up to 300 degrees Celsius. And lastly is white reactors. White reactors are easy for visual observations in colorful chemicals, for example, photochemical reactions. Nowadays, reactor manufacturers are constantly updating their product lines to meet the demands of this industry for procedures that require for small volumes, high doses, lower temperatures, and higher levels of confinement.
In this session, we will be continuing to focus on the advantages and disadvantages of the application of this type of reactor, which is glass-lined reactor for the industrial purposes. The first advantage of glass-lined reactor is that it has a high level of chemical resistance. The reactor is coated with glass, which is fused onto the surface of substrate material at high temperature. This process is repeated until the desired glass thickness is achieved. This thickness can resist a high number of chemicals. Another factor that makes glass-lined reactor preferable is easy cleaning process. This is because the surface is hardly polished during manufacturing process. The reason to have the surface polished is to avoid cross-contamination. As a result, the surface cannot affect the properties of the contents such as flavor, color, or purity. This makes glass-lined reactor to be physically strong and capable of handling a wide range of high pressures and temperatures. High corrosion resistance is one of the most significant features answering to why pharmaceutical sectors to utilize glass-lined reactors in the industries. High resistance to corrosion makes inorganic acids, and organic solvents with different concentrations to be more applicable. This table shows how glass-lined reactors are more beneficial than stainless steel reactors. 6 features are utilized to compare between 2 reactors. 3 features, which are corrosion resistance, contamination, and cleaning, are already discussed during previous session. Another feature to be discussed is economy. Glass-lined reactors' lifespan increases due to superior lining, meanwhile stainless steel reactors require more maintenance by changing the vessel with increased frequency over time. In addition, glass-lined reactors cost less, where basic steel products require greater cost. Despite benefits that a glass-lined reactor provides, there are still limitations to the application and the features of glass-lined reactor itself. There are some chemicals applications that are less favored by glass-lined reactor. This includes alkali, hydrofluoric acid, fluoride, bearing medium, and phosphoric acid applications with concentrations above 30% and at temperatures over 100 degrees Celsius. Unfortunately, glass-lined reactor has a lower tensile strength and is typically more brittle than steel or other metals. These shortages make other reactors to be more beneficial.